Now we're going to apply the formulas for antiderivatives from Note 98. So you want to have Note 98 sitting in front of you while we do this problem. It's going to go fast. You can rewind it, take a look at Note 98 to see why the answers are what they're turning out to be. Okay, we are given, we're asked to find all functions f such that the derivative of f is equal to 3 times the sine of x plus 1 over x squared plus 2x to the fifth minus the square root of x all over x. The reason they ask us to find all functions, what they're really wanting us to do is add the arbitrary constant c at the end after we carefully decipher each term and evaluate the f for each of those. In other words, we're actually looking for antiderivatives here if you think about it. This is kind of complex to think about. What is an antiderivative? Before we start, let's look back at, let's see, note number 97. The antiderivative of a function is the function whose derivative equals the first function. So if we're looking for the antiderivative of f prime, we're looking for the function whose derivative equals f prime. That means we're looking for f of x. Okay, so when they ask us to find f of x, when they give us the derivative, they're asking us to find the antiderivative of f prime of x. Okay, let's do it. First step, we will decompose this given function into pieces. 3 times sine x plus 1 over x squared can be written as x to the minus 2. Now let's bust apart the numerator here. 2x to the fifth over x minus x to the 1/2 over x. And we can simplify first. That implies that f of x is equal to, f prime of x is equal to 3 sine x plus x to the negative 2 plus 2 times x to the fourth when we simplify the term minus x to the negative 1/2. Okay. There's our different terms. Let's apply our formulas. F of x, this is the antiderivative of f prime, is 3 times negative cosine x. Okay, hold on just a second. The reason it's negative cosine x is because if you take the derivative of negative cosine x, you're going to get a double negative sine x, which simplifies the sine x. Okay. Continuing, we have x to the negative 2. We're finding the antiderivative of that. That will be 1 over negative 2 plus 1 times x to the negative 2 plus 1. That comes right from the formulas. Now the antiderivative of 2x to the fourth is 2 times 1 over 4 plus 1 times x to the 4 plus 1. And then the derivative of x to the negative 1/2 is 1 over 1/2 plus 1 times x to the 1/2 plus 1. So these are all acquired using the formulas in note number 98. All right, let's simplify. We get negative 3 cosine x minus, that turns out to be a minus 1 times x to the minus 1 plus, this turns out to be 2/5 x to the fifth minus 1 over positive 1/2 times x to the positive 1/2. Okay, continuing, that's negative 3 cosine x minus 1 over x plus 2/5 times x to the fifth minus 2 times the square root of x. But that, of course, is not all the functions that there are. To make sure that we have all f of x, we have to add the arbitrary constant c. You cannot forget that. So our actual answer is f of x equals negative 3 cosine x minus 1 over x plus 2/5 times x to the fifth minus 2 square root of x plus the constant c. That is, for any real number c, that's infinitely many functions that I've given you there in one box. All right, because c can be any real number, and it represents all the functions f that have the derivative that was given to us in the question.